Let's move on to the third video, tackling class imbalance. In the previous video we looked at building non-linear classifiers using SVM. In this video we're going to take a look at how to tackle class imbalance caused by a classifier. Until now we dealt with problems where we had a similar number of data points in all our classes. In the real world we might not be able to get data in such an orderly fashion. Sometimes the number of data points in one class is a lot more than the number of data points in other classes. If this happens, then the classifier tends to get biased. The boundary won't reflect the true nature of your data just because there is a big difference in the number of data points between the two classes. Therefore, it becomes important to account for this discrepancy and neutralize it so that our classifier remains impartial. Let's see how we can do this. I've created a file called svm-imbalance.py. We need to add these lines to load the input data. Let's visualize the data. The code for visualization is exactly the same as it was in the previous video. You can also find it in the file named svm-imbalance.py. Now let's run the code and see the graph of input data. This is the graph of input data. Now let's build an SVM with a linear kernel. Let's go back to the editor. So this is the code for creating the training dataset. Let's run the file. There, we have the output. This is the training dataset. You might wonder why there's no boundary here. Well, this is because the classifier is unable to separate the two classes at all, resulting in 0% accuracy for class 0. You'll see a classification report printed on your terminal. Let's go back to the editor. This is the code to evaluate classifier performance. Now we'll run the file again to see the accuracy report. So this is the accuracy report. As we expected, class 0 has 0% precision. So let's go ahead and fix this. We'll go back to the editor and replace this line with this one. The class weight parameter will count the number of data points in each class to adjust the weights so that the imbalance doesn't adversely affect the performance. Let's run the code. This is the output. Let's look at the classification report. Precision has changed to 0.39, so class 0 is now detected with non-zero percentage accuracy. Cool! So that will be all for this video. In this video we've learned how to tackle class imbalance using class weight parameter. Great! In the next video we'll go through extracting confidence measurements.